Hi there, my name is Mike Dahlgren. I'm a cloud solution architect for Red Hat. And today we're going to talk a little bit about modern application development and really how that fits in a broader framework of digital transformation. So the first question is really, why are we here? And part of that is really, why change? If everything works fine, why break it? Why fix it now? And the answer is, things are changing now faster than they've ever changed before, but for not only from an IT standpoint, but from a business standpoint. And so, first off, IT leaders have been saying change is coming for a long time, and they're saying that change is still happening. So, 87% of people believe that their industry is going to be disrupted by digital trends to a great effect, great or moderate extent, right? But the problem is, less than half of companies believe they're adequately prepared for when that change takes place. But it's more than just that, because businesses themselves are changing. 50 years ago, the average Fortune 500 company had been on the market for 75 years. Currently, in 2015, that's less than 15 years. And not only that, but the rate of that change is accelerating for turnover for large companies. So they're expected that by 2020, more than 75% of the S&P 500 will be companies that we've never heard of. So think about that. 3/4 of the people we know now may not be here in just a few years. Finally, the environment's getting more competitive, but more importantly is IT used to be seen as a way that business got done and also as a cost center. But more and more likely that CIOs are now being told that their IT organization is actually a way that the company needs to generate revenue. And so this is an important change, because before, what used to be just like a plumbing environment where things had to be done and services were provided, is thinking there's like, this is where the value comes from for the company. And so what we have is these three things, is where we're saying, we know things are coming, we know people need to have change, we know that the businesses themselves are changing, and we're not prepared for it. And this is the idea from where we start today. This is the thought that we have in our heads as we figure out, where do we want to go in the next 5 years, the 10 years, and so on. And this is a harder problem. And we think we understand it, and we think we know where we are, but it's really not that easy. So we're on a plateau right now. We're on a precipice, and we're trying to figure out, like, what does that look like to be successful? And so in this example, it seems easy, right? Like, here we are, and we're looking out, and it's like, this looks great. But once you see what's out there, you realize that the end result is way more treacherous and fraught with issues than we really think at first glance. And then the other question is, where do we want to try to go? What does success look like, and how do we get there? So today's conversation is really going to be a story of two paths: the traditional IT path, and through all the troubles and tribulations that it involves, and the direct path. How do we shortcut that process? How do we go from the shortest path between A and B, and how do we use that to get stuff done? So before we get into what traditional IT looks like, we see what's ahead of us. We know it's going to be a challenge, and we're faced by a problem. We could go forward. We could walk through this. Our employees and our customers could go with us. But unfortunately, a lot of times what they see instead is greener pastures. And so maybe it is greener on the other side. And we're starting to see this as a generational issue as much as it is as a change issue. And so 60% of millennials have changed jobs between 1 and 4 times in the last 5 years. What's more crazy about it, though, is almost half of them plan to switch jobs within the next 2 years, and 2/3 of them switch jobs in the next 4 years. And so the long-running employees that would get stuff done, you can't rely on. Not only that, it's going to be difficult to get them to do the things that you might not want to do because they'll go somewhere else. And so let's talk about some of those difficult things. What are these pieces along the path? Well, the first one is really, from an IT perspective, is dealing with proprietary and monolithic systems. And this is a real headache because it's a very difficult thing to maintain, and it's projected that up to 80% of IT spending lives in this space. They're in the Sarlacc pit. They're trying to make things happen, but the process and what is there is such a difficult thing to work with. It just doesn't happen. And this is when the talent bounces out. Like, not only do we have a cultural issue, but nobody wants to be the person that has to fight this monster. This is not a place that they want to be, and we can easily lose them to it. The second one is we have to worry about the skills gap. And this is becoming a bigger and bigger issue as time goes on, because not only can companies not find the workers, almost 3/4 of companies say they cannot find the qualified workers they need, but at the same time, the workers they do retain are not keeping up with the skills that are necessary to be competitive in this market. Next, we have a lot of legacy practices that are employed today. And just to name a few, it's crazy when you think about how half of companies out there do not have a patch policy in place. Nobody likes patching. They really don't. But it is absolutely critical from a security and stability standpoint to make sure everything is updated and it works as it should. What is more scary is 50% of those people, so 25% of those companies, don't update things at all. Once they put a system in place, they say, this is perfect, this is how it is from now on, and they will not touch it until it becomes a real issue. The other issue with this is the time to market is extensive. So how do you innovate if it takes not days, but weeks or months or quarters or even years to get a new system in place? If I order a new application, how long does that take from concept to production? For most companies, it's at least 2 weeks. Some of them, it's in the months. Now, if we make it to this mountain, we can get up there, but a lot of times it takes a huge amount of manual effort. And this has been a huge change as well, because if you look back 10 years ago, the definition of a good software product really came around what did it look like? Do I have like cornflower blue icons, rounded corners? What does it look like? How did that work? Today, that's not really the case. Today, what we're looking for from software is how do I manage it and how do I have software talk to software? I don't care about the icons. I care about the API. I don't want to have people manually pushing buttons to get things done. And I would go as far as say, if your IT business requires people to log in and push things manually, from an IT perspective, that system is broken. Like, it really shouldn't be the case, because we have the software, we have the solutions in the space to make sure that's something that you don't have to do. So even if we throw all the manual labor at this, we're still not necessarily going to be successful. More often than not, good IT projects and good IT skills are destroyed by bureaucracy and levels at the top where choices are made that do not fit the company's best interest. And so it's hard when the best ideas can't succeed. How do we succeed as a company together? And so what we have here is that's the route of traditional IT, and that's the point of why we're here. Now, what is that shortcut? What is the shortest path between 2 points, right? Well, that line is what we call digital transformation. And that's the way of reevaluating the way we do IT, but also businesses and the newer manners and updated processes to make sure that we don't have to go through the mire that we just discussed. So what does this look like? Well, it really comes down to 3 primary silos, and that's of process, of infrastructure, and of architecture changes. And we've seen a lot of this over the years as things have slowly changed, but now we're at a new precipice of getting to a real results. Because before, our traditional methods of, let's say, waterfall development, they've been giving away with agile. We cannot wait quarters and months and years to get new components or new items released in our software. We need these things to be faster. We need to break off smaller pieces. We need to get time to delivery reduced, but also to cut down our risk footprint. At the same time, these faster iterations actually require us to provide real DevOps practices. We do not have time for developers to throw code over the wall and for operations teams to maintain it. This isn't something that we can do anymore. We can't afford that kind of weight and that kind of separation. From an infrastructure standpoint, what used to be pretty easy was standard data centers, because we could go around and look to see, what are my things? What are these beige boxes doing here? How long have they been? How do I audit them? How do I keep track of them? It was a pretty static, but also a very understood model. But it was also very expensive. And so there's been a migration to saying, why don't we do managed services instead, where we'll pay other people to manage our data and our data centers and our services. But the problem with that's not ideal either, because it's also more expensive typically. There's a lot of overhead associated with having somebody running it per hour and not per item. Well, the beauty here is that we can have our cake and eat it too if we go with the best of both worlds. And that's really about the hybrid solution, where maybe I have one cost for a set load and then a bursting cost for another. Well, why would I care? Well, let's say I'm a large retailer and I know that I'm going to do half of my business in 3 months of the year. And the last thing I want to do is build a data center 3 times the size that I need because 1 or 2 days of the year I'm going to spike in traffic and I'm going to turn people away. So what I can do is build a data center for a certain size that I need, a certain base load, and then use that to burst up to the level I need on those hot days. And so the last thing I would ever do is send my customers or potential customers a 404 page when I could just burst up to the cloud or burst to another solution. The third part about this is really around architecture. And so historically, we had large mainframes. Everything was very monolithic. You could point at it and say, that's exactly what this is, and it's all there. But as things get more complicated and we have different scaling requirements, we broke things up into an interior architecture. And this is good because it adds flexibility. I can have load balancers and firewalls and web servers and application servers and database servers. And each one of those is a tier in my stack. And if I need more web servers, I could go from 5 web servers to 10 web servers, and I can double my capacity at that level. And I had more flexibility with this. The problems is still could be improved because it's not an easy thing to do, and it requires a very different set of skills for each tier in the stack that different people may have to manage and maintain. Well, what we can do is actually break this up one more level into microservices. And so now each piece is roughly as small as it can be, and I can scale any part of the solution to any level I want. And now when you look at like .com booms and how did we get there, they're not growing 20% or 100% a year. They're growing 1,000% a year or 100% a week. And the only way you can do that is by having microservices that we can scale and horizontally level up as we require those resources. So this is all good and all, but how do we get there, right? This is all just words on a page. Well, that's really where Red Hat comes in, because what Red Hat's about is enabling people to get to these places using the technology and the skills and the software that we provide. And so it's not easy, but there is a lot of steps here that we want to take into account. The first thing is about modernization, right? We want our applications to be modern in such a way that they can work in this new environment, but also that they want them to be cloud native. And so it's not good enough that I've modernized my apps just to live in my data center because I lose out on all the burstability and all the scalability that I get with public and private clouds. Another key part about getting there is with containers. Man, a lot of people talk about containers, and while we think they're a new thing, the concept has been around for a long time. But what containers really bring is about portability. And with that portability, then we get to talk about developer ops, where we can say, we got to work together on this, and each one of these steps in this ladder is what gets us to a total solution. Now, we know what we have to do, but what does that look like? What is the solution there, and how do we make this all work together? And so Red Hat works with millions of open source projects, and we turn them into many different solutions. And the one that's probably the most important in this space is OpenShift Enterprise by Red Hat. Because what this is a new way to think about the enterprise that allows us to do all the things that we talked about in a continual single button push managed environment. So let's talk about OpenShift and really what are the parts that make it up. Well, before I get into OpenShift, I do want to mention a little bit about what is a container. And as I said before, this is not actually a new concept. Containers have been around for a very long time in some way or shape or form. The old Solaris zones was very similar to how a container works without the portability. The idea was, how do I put the stuff in a box and keep it? Now, containers are really quite brilliant because what they remind me of the most is the old style cartoons that were painted with cell shadings. What you're doing is building up these different layers of a scene or a background, doing it one layer at a time. And so if you were drawing a cartoon, you would probably start with a background scene, and somebody would hand paint this background of trees and grass. And then they'd build a next layer up, which might be the protagonist or some kind of foreground item. From there, you'd put another layer up, and it might be another character. And then on top, you'd have the foreground pictures. And so what you do is you layer each one of these cell shading transparencies on top of each other, take a photograph from the very top, and that was your one frame of film. Containers are very similar to this because they work the same way. They work bottom up, and they're immutable. So once I paint the background, I can't go back and retouch up the background. I can only change the top layer of my transparency. So in the container world, We don't deal with virtualization. We don't deal with any of that overhead. But what we're talking about is different layers on top of the operating system and a way to constrain them. And so we start with an OS layer. And instead of being a hypervisor, what we're really talking about is more like glibc. Like, what are the libraries I need to actually run applications on this service? From there, we can build up stuff like Java or Apache or maybe our application code. And each one layers on top of the old one. So there's a lot of advantages here. First off, like we said, the layers down below are immutable, but also it's very prescriptive. I know exactly what I have because I build it out fresh each time I do it. And so no longer should I have to worry about thousands of packages and hundreds of thousands of files. I can say these are exactly the things that are included in my container, and here's how they get built. The other part about that is once I build it, this is also portable, but also I can reuse different layers. I can say, you know what, I'm going to use the Apache layer and below for another service. And I don't have to write it down twice. I already have it. I just referenced the first one. So this also provides new levels of scalability that we just didn't have before. The next thing I want to talk about is really the change with how do these things get done. And so we talk a lot about CI/CD process, or continuous integration and continuous development. And what this means is my end user should be able to go into my system, go into a system, talk to his code repository. It doesn't even have to be part of OpenShift. He checks in some code. She then hits commit. It goes into the system, and then the magic happens and a container spits out the other side. With OpenShift, most of this work is done by source to image, but in reality, you shouldn't ever care that this is how it gets done. Now, once I have these containers, the beautiful thing about their portability is I don't care where they run. These can run on virtual machines, physical machines, private cloud, public cloud. It shouldn't matter because the container format is the portable agent. And if I want to deploy a new version, well, I just click the button. I have a new release of my software. And it goes through this process and spits out a new container on the other side. Now, what OpenShift really is a modern application platform. And so the best comparison here is most people are very familiar with Red Hat Enterprise Linux, which is an operating platform. You install your applications, you make your configurations, you do everything at that level. Other people from the data center work at the hypervisor level. So they don't even care about the OS, they start one level below. But what you don't necessarily want to do is deal with all the details that come with it. If I'm an application admin or if I'm an operations guy, I don't care personally how the work gets done. I just want it to get done. And so if I want to run a new application in a traditional environment, I'd have to build out the OS, install the packages, deploy all the hardening guidelines and scripts on that, backups, monitoring, email. These are the things you'd have to configure in an operating system. But you do it every single time you need a new system. But with OpenShift, that part is all handled for us, and it's handled in a very scalable and supportable way. And so I don't care about the operating system at this point. What I care about is my applications. And I say, I want to put my application on this OpenShift node. You handle all that part below it, and then you just make it happen. The cool part about that is I don't care where it runs. It's going to be public and private cloud. But what I care about the most is, do I have the things checked off that I need? Is it scalable? Is it monitored? Is it backed up? Do I have alerting? Do I have logging? These things are already handled for us, and we don't have to deal with them directly. From there, we can run just about anything we want on the top. For the most part, if you can run on Linux or Red Hat Enterprise Linux, it'll run on Red Hat's OpenShift. That's a fantastic solution for something that is traditionally a very difficult problem. So what is the runtimes here? Well, I could build out these containers like I showed before, one layer at a time, but I don't want to start there. I don't want to have to manually say, I need Apache, I need Java. What I really want to say is, hey, I have this Python, this Python or this Ruby code. Can you just give me a runtime that has Ruby already set up and all the layers and all the parts I need to make that happen? And that's all a runtime is. And so from a developer standpoint, I say, man, here's my new code X. I need the appropriate runtime, click go, and a container spits out the other side. With that, all the management and all the API management and metrics and code work and all that stuff comes with this because it's all part of the runtime, and the pieces I need are loaded based on what I'm trying to get done. The other thing we want to talk about is really we want to architect for smaller components. And so what we talked about before was actually with mainframes and how it's one giant monolith, and that was actually broken up by many different machines. Traditionally, those have been virtual machines, but let's say you break up one giant system into 4 or 8 little virtual machines. Now, the next step is how do we break that up more into different microservices or containers? And that's part of the same, this is all a continuation along the same path. There's a lot of good things that we come from this. Obviously it's agile, it's DevOps. We mentioned that a lot, but it really allows scalable. It makes it more scalable, but it provides for new architectures. I'm not locked into any one proprietary system anymore. I basically define the container, and then anything can run that container is my new platform. Now, there are some negatives with all this. If we're breaking up a monolith into a bunch of chunks, we're going to make it more complex. There's more pieces. There's more data places where the things can live. But this is where OpenShift is also really key, because I would say if you're managing your containers by the container, one piece at a time, you're also doing it wrong, because OpenShift doesn't care about the container, nor should you. What you really care about is the whole package. What does the project of the monolith look like? If I have my project X, I don't care how many containers it necessarily runs. What I want to say is my web tier should have between 400 and 400 containers. You manage how many of those run. Say, OpenShift, go take care of this for me. Scale this up as I need it, scale it down as we don't need it, and do that for all the parts of the application and let it handle the details. And now instead of managing a dozen different virtual machines or thousands of containers, I just want to manage one project and say, here's my project. You take care of the details for me. So what does this look like? So once we have this container platform, it really makes a level playing field for all the different environments. And so, like I said before, we can scale up each one of the containers as many services as we need, but we can also run them anywhere we need because it's portable and all the data can go with the container. And so really changes the way we think about IT, but it really flattens and levels the playing field across the board for how we think about IT and how that work gets done. So what are the results of this? Well, honestly, it's been fantastic. And if you think about most of the .com companies out there, they don't do stuff the way that we did before in our legacy environments. It's not something that you would ever go back and do. And so what OpenShift does is allows businesses to act like a new .com agency, but still maintains the control and the policies around their existing infrastructure. But the results on this, like I said, are phenomenal, but really from time to market and from getting stuff done, we're looking at 5-year ROIs of over 500%. We've seen the average annual benefits per 100 developers as being over $1.3 million and a payback period of less than 8 months. I mean, OpenShift is probably one of the most exciting technologies that's come out of Red Hat in the last 10 years. And there's a reason why, because it is taking off, because it's solving real problems and making things happen at a scale that we just didn't have before. So that's OpenShift Enterprise, but that's how you start. And so that's a point of mine is a lot of companies think that they have to build out the infrastructure to begin or to get to where they want to be. And I would actually argue that if your definition of success is that they've built out the infrastructure, you haven't succeeded, you've actually just started. And so instead of having to do that all by hand, OpenShift is the way to build out the infrastructure at the very beginning and say, we're going to start here with a full CI/CD pipeline with all of our integrations, with all of our, across any platform, and then we can go from there. But to be successful, we have some other steps along the way that can help us in this process. One of the key ones is about having a methodology from Red Hat around modernization. Just taking your old legacy applications and throwing them inside of OpenShift or in a container isn't going to gain all the benefits that you would get from a full modern environment. And so Red Hat does a lot of work around the methodologies, but we'll come out and talk to you about what this actually looks like. And so step one, we discover what's going on. Discovery sessions are a big part of this. Document, what do we have? What should it look like? How do we want it to work? From there, we can actually go ahead and make designs. Say, let's analyze this. Let's use data to prove what works, do some POCs or pilots, and then plan an action plan to get something to happen here, to get this done. And then finally, actually deploy it. If we're going to make changes, what does that look like? We got to actually do something with it. But the important thing here is it should be iterative, right? we're not going to rewrite the world. We're not going to boil the ocean. We say, how do we fix this? And we iterate quickly to say, how do we make changes here that we can process and work with at the fastest scale that we can possibly do. The second thing that's really cool from this year is OpenShift IO. And really when people say, what is OpenShift IO? It really is a developer platform as a service. Instead of saying it's like no duct tape included, right? You don't have to develop your own CI/CD pipeline. You can if you want to, then more power to you. But OpenShift IO is that end-to-end solution where my developers are committing code directly into OpenShift IO. You can use your own IDEs or even the web UI IDE that's built in. And from there, you have all the different, project planning and tracking and work items and assigning of tickets and all that systems built in OpenShift IO. And from there, they can go ahead and once they click commit, it goes to the full CI/CD of testing, deploying, and monitoring as it goes through the process from being built and tested to actually being running inside of OpenShift. And so OpenShift is really that end-to-end solution here to say, you know what, if you want to bring your own pipeline, that's great. If you want to bring your own kind of build system and ticket tracking system and all stuff, more power to you. But if you don't have to. We have that right here for you. Now, the final piece, and probably one of the most exciting, is about Red Hat Innovation Labs. And their goal is really twofold. How do we work with you directly to figure out how do we modernize your traditional applications, but also do we develop like new environments and work with these next generation principles that we discussed earlier? Let's work on lean and agile principles. Let's do the DevOps directly. And the important part about this is not about consulting or staff aug. It's really about teach so others can teach. How do we come in here and work with you to collaborate together and be on site and figure out how do we improve the situation? How do we make things work better? And also, how do we let you guys run from there? Now, what I think separates Red Hat the most from anyone else in this kind of space is Red Hat is by far the largest open source company. And so, as I said, we work with many, many communities and we're very active in the space. And those communities and that action has been a huge part of our success. And so it doesn't come easy. This isn't no magic bullet to communities. It takes time and effort, just like all the other things that we do in IT. And what Red Hat will come in and say, hey, how do we incubate with the community? How do we interact with that? And how do we teach and train those skills to work with other groups in the larger community? Because we are all in this together. Everybody thinks they're trying to solve the same problems or they solve the problems for themselves. But in the reality, we're all working to solve these hard problems. And through the community and through sharing and collaboration, can we develop a solution that works for all of us? And we get the best of all. So what does this look like? Well, today we've done two things. We described two different tales: the traditional IT trail that involves a lot of legacy and monolithic environments and difficulty maintaining and retaining good people, and the people that we do have are doing tedious and bureaucratic processes that really don't provide value to the company. The second one is let's shortcut the technology, start out with a platform that allows people to iterate quickly and successfully and work along the digital transformation line that provides the shortest path between where you are to where you want to be. And this really is the key of how Red Hat unlocks the future of business. So thank you so much for your time today. I really appreciate it. And if you have any questions, please let me know. Thank you.